My name is Katherine Mirica, and my research focuses on making gas sensors from carbon nanotubes. These sensors might ultimately find applications in the food industry, healthcare, and homeland security. A carbon nanotube is a tube-shaped molecule made up of carbon atoms. It is 1 to 10 nanometers in diameter, which is 50,000 times thinner than a human hair and about 1 billion times thinner than this model of a carbon nanotube. Carbon nanotubes are chemically related to the main component in the lead of a pencil, which is graphite. Graphite is composed of flat sheets of carbon atoms. If you take one of these flat sheets and roll it up into a cylinder, you get the structure of a carbon nanotube. You can view the nanotube as a very conductive hollow molecular wire because all the atoms of the nanotube are on its surface. When something else like a molecule interacts with that surface, it can have a very large effect on the flow of current through the nanotube. And this type of sensitivity is very useful for making sensors. Our approach for overcoming the challenges of working with carbon nanotubes relies on a solvent-free method that is essentially similar to drawing with pencil on paper. Instead of using a graphite-based lead like a regular pencil, we make our own lead that's composed of carbon nanotubes. To make our pencil lead, we take a commercial powder of carbon nanotubes and compress it into the shape of a lead using a press. To make the sensors, we take a piece of standard copy paper and deposit gold electrodes onto its surface. These electrodes help us measure the electrical current running through the carbon nanotubes. We then take our pencil lead and draw our carbon nanotubes-based sensor between the electrodes. And that's it. We've just made a sensor that's capable of sensing ammonia gas at low part per million concentrations. Sensing ammonia is important because it's a toxic gas that's sometimes used in refrigeration and food processing applications.